Hey everyone, came back for another module. It's a Linux file permissions. This is the logo that I modified from our Mercy College logo for our cybersecurity. A special announcement for you all. October is the month for nationally designated cybersecurity awareness. So at Mercy College, our cybersecurity program, and also Center for Excellence in Cybersecurity organized the event this year. In this year, the event will be on October 20th, which is a Thursday night. So I want you to plan to join our event. All right. So details will be emailed to all of you sooner. But anyway, yeah, this is the logo. Why file permission? Why file permission is important? And more for cybersecurity measures. You know that, for example, the server or web server or anything, any services that you allow people to come in and look at and use, then you need to at least do not want anybody who do not trust in your system. So you need to have some control over user access, right? So that is wait a minute, this is not right. Permission command. Right. So so what I'm going to do is to give you some of the overview, and then we'll look at not all of this, but a few of those. Okay, ID. If you type ID, then it displays user identity. All right. So let's get in the system. I'm going to do it one more time with you. So if you look at this, there is a pointed sec remote. Right now are disconnected, so you need to right click on it and then connect it to. By the way, this is already set. And we are in the VPN, and click on this PuTTY, and I'm going to log on the Ubuntu on Silo 2. So double click on this. Alright, so I am there. I can put my login name and password. When I try to check who comes in our system, this WTMP, this is a logging files restarted from October the 1st, right? Since October the 1st, only Mr. Turner came in, right? Okay, so here if I type ID, then it shows who I'm Jae Yoon, and faculty. This is the group that I created, and that is a group ID. And also I have a sudo privileges. Okay, super user privileges is something that I am. See here in this slide, there's a SU, super user, and sudo. So super user privileges can be executed. So I am in that list. You are not. If you have a sudo list, then you can do anything that you want. So we prohibit that. Okay, but keep in mind, if you are in this sudo list, then you can install new packages, and also you can create a user account, you can create user password, and you cannot once you assign user and password, then you cannot do on that account, on that the home directory, but you could do as sudo, okay, because you do not know the login name and password of another. Although they are in the same system, it is impossible unless you do have sudo. Okay, although you have sudo, it is impossible to know your password. All right, but anyway, so first thing that you need to do is that if you want to change your password, then you can simply say passwd. Then it'll ask you enter your password. Okay, so I assigned to you the password, but those passwords shouldn't be all the time same. You can change your password as far as you are here. Say, although you are not sudo, but you can change your password because that is owned by you, right? So you can change yours. Right now, this is me, and that appears here, so that I can change my password. You cannot change my password. I can change my password. You can change your password. But as a sudo, I can assign your password. Okay, this is the change. If you want to change your password, you simply type passwd. Suppose that you are sudo in the sudo list, then you can do sudo and password, and someone else password. For example, DTURNEL 1 or 10, maybe 10 or 1, right? Then you can change his password. But this is the case that if you have a sudo, okay? Right now we do not have that. CH mode, so change file mode. Let me see from next to security and all others. So I'm going to explain a little bit, and then we'll get back to that. And the umask, which set the default file permission, and then chown. Each file has a ownership, so you can change the ownership also. If you type ls-l, then see here the owner is this, right? So if you want to change this owner to someone else, can be changed. The group also can be changed. This is the group, right? And then password that we just looked at. I'm going to explain a little bit before we get back to this practice. So what we will do is to give you okay. Okay, Linux security. Linux has a very strong mechanism to protect your resources. Unless you open the door, unless you are carelessly to remove default settings, then Linux is the best platform, which cannot be compared with the Windows. Okay, so that is the most popular, and also a lot of things that you can do for protection. Many features available so that you can attack others through your Linux operating systems, and also Linux operating systems may be able to be attacked. Our department has servers set up, actually 4 silos. So silo 2 is the physical equipments installed, and within that physical server, we installed the multiple platforms. One of those is the Linux Ubuntu operating systems. That is where we are right now. Okay, so Linux can create highly secure systems. So we will review discretionary access control. There are 2 types of access controls: mandatory access control and discretionary access controls. Discretionary means, let's see if we have anything here. Yeah, this is a very typical discretionary access control. By considering 3 things: subject, object, and action. Okay, subject, object, and action. So subject, that is the user or process. Why process? These days, if you want to attack any system, then you do not need to log in as your credential, but you can run a program. So that program may try to access the system. So in that case, that is a process. Process is nothing but a program that you may create. Okay, anything either user or process, it will be a object. This object wants to touch. This subject wanted to touch objects. So objects could be file, directory, or any others. Okay, so that is our objects. As a subject's access objects, there is a purpose. This subject wants to take one or more actions. Okay, that is action. In operating systems, the action could be one of those. May wants to read the content of the file, or try to modify, so write on it, or if the file is executable, then run it. Okay, so basically those are 3 actions are the purpose of a object wants to come in. So for these 3 things line up in a way that a user Jae-yoon wants to read a file name called the password, PASSWD. then your system needs to make a decision. So whether that request, subject action object triple request is permitted or denied. Okay, so as it is requested, the permission is already set to each file. Each file has, for example, what is the owner, what is the group, what is the user, what is the group, what is the others. So all such things are already set. Hey, the owner can write on it, and group where this owner is involved can read it, and others, this is a general, simply the world cannot do anything else. That type of description needs to be specified for each object. Then when user comes in, then it verifies it. Is the user, is this subject the owner of this object? Is this the subject in the same group as this owner, or just in the world? Depending upon that, we can do some. In this description, it also says, is it allowed to read? Is it allowed to write? Is it allowed to execute? So those three things, for those three groups, will be specified in this object description. Okay? So that is discretionary access controls. It can be open to public, anything, so that then more services available from a specific file, but vulnerable at the time, right? So we'll look at that. Linux traditional security model is that people or process with root privilege can do anything. Other accounts can do much less. So root privileges can be a root itself or anybody who is in that sudoers list. Okay, anybody who is in the sudoers list. Let me see if I can. So here, if you want to see the sudoers list, then you need to, where I am right now, if I type pwd print working directory, then that is within me, right? So I need to, okay, it's clear. So I need to go back to, or I can see simply ls etc. Okay, then a list of the files and subdirectory within /etc. etc is on top. So there is a file called sudoers. So if you want to see sudoers file, then sudoers no such file or sudo oh, it should be on top /etc/ right. And then you can see here some of the code here. This tells you the access mode. So by reading this code, you can say, oh, can I access? If I access, that which actions available for me? So it looks like right now is read may be possible, but we do not know. Read is given to who, right? So basically, the second character from left, each three characters tells us some permission for each different groups. The first three characters tells us the owner of this can read. So owner is who? Root. Root can read. And the next three bits is the group, root group, or pseudo group is also allowed to read this. And the last three characters describes the world. Whoever in this system can do whatever described here. So in this case, anyone but root or somebody in the pseudo words list cannot do anything. There's nothing written, right? Not like this, read or whatever. So if I want to read this, see what happens. How can you read? There are a few other commands possible, but in this case, you can say more. Can I see? Can I read? So if I do that, then it says it cannot open. It's not allowed to me, Jae-yoon only. So it may be possible if you are in the pseudo words. This Ubuntu operating systems already know that I am not the root, not a root accounts, right? So only if it is possible if I am in the pseudo words list. So right now permission denied. If I want to, then what I need to do is I need to sudo space and more. The rest, the command remains the same. If I type this, then it asks me to enter my password so that I can put, then I can see read because I am in that list, right? So user privileges specification root. So root has all the privileges. And then admin can do, sudo can do, or pseudo words list within this pseudo words.d where there is some list, then it is also possible. So we can do a little more. Go to that pseudo words.d, then there is a readme. So that readme, and then you can do read more. Definitely you need the sudo and read more, then some of the description about that, right? This will cause sudo to read and parse. Yeah. Okay. So that's what we have seen. Yeah, those two files. That's what we looked at. And file system security in Linux, everything is a file. So directory is a file. Any physical the file itself, that definitely a file, or any link symbolic link. So there is only the labels, but not the reality, not physical file itself, then that is also a file. So everything means memory, device drivers, pipelines, whatever the resources will be treated as a file. Hence, file system security is so important. It is very straightforward and controlled very tightly. I/O to devices is via special file, so that is also available in DEV, device. So for example, if you look at DEV, then it's all the devices that you can think of. TTY, this is a terminal, so you can, this guy gives you how many terminals? About 64 terminals by default available. And if you see here floppy disk or CPU, that is also the device, disk, and this is a real device that is connected to, mounted to this. So if you want to see that, then you can see in this way. So SDA it has some log files stored. This is a links. Okay, see if here, see this is file, log file is a link. It's not the directory, but it is a link. And first three, the user itself can read, write, and execute. Anybody in the same group, read, write, and execute. Anybody in the world, read, write, and execute. So you can read it, you can execute it. Execute, one of the execution is that can I change the directory into that? Yes, it is possible too, right? So if you want to do, for example, CD and then DEV log. Oh, it is not a directory. So, but you can see, you can, for example, you can see the type of that file. If you type that, then it says a symbolic link. So, can we read? So you can say more. No such file devices or address. Symbolic link. It's not a directory, but it's not also a symbolic link to that. Cannot open. No such device or address. It's not possible. Yeah, it's not. But anyway, this is one of the example. And CD-ROM, if we have CD-ROM, then CD-ROM is one of the device may be able to be mounted. Okay. Right. And user groups. As I said, user has three different levels. The lowest individual level is user itself, and then users are grouped into a specific group. You can create a group as we have, for example, faculty or students, whoever, then that is a group. For example, CD, and if I want to go up one more level, so that if I want to see all, then look at this. This is the students, for example, okay? Then this is the owner of that students, and that owner of this directory. This is the owner, and this is the group of that, okay? So we can see who were able to log in so far. We have September 1992. Yeah. Somebody's not quite, possibly, I'm not sure. For example, this particular LMARER, see if he has any LMARER. He hasn't created anything, but somebody who actively logged in, who might be let's see. You can see also he didn't create any. Not many students created anything at all so far. If you want to see who creates anything so far, then CMSI, he created directory password, is doing well. Excuse me. Jaeyun, this is me. And Word. Not many students try to get in. This is important. To do some work within this server is very, very important. I want you to practice. Right now, when I see your directory, not many students came in. Of course, if you have some footprints here, which means there's some evidence that you log in and you created, you practice something here, then I can tell, oh, this guy is working. At least I want you to do that. I mean, once come in. Those who have Windows definitely should come in. Mac OS, then you can also come in if you are in our lab. I want you to come in at least a few times the semester, so that I want to see you here in this server. Your work domain in your life is not only one single system, but you should do something for the server side. So I want you to come in the server side and see what is available. Okay. So this is user group and users. Okay, detailed. The password may be kept in this one, but real password is not stored here, right? If you see, for example, I can go back to myself, right? So I can see etc PSSWD, then this is now right, so it should be WD. Then you can see it, some of the, see here, let's take one example, J. Jackson. This is his own ID, this is a group ID, and this is his name, this is his home directory, this is the shell, it's a bash shell, it's the shell, this guy, and all of us are using bash shell. And this is the login name followed by X. This is a password, but password is not given by this password file. Okay, it is actually stored somewhere, so-called shadow. But let's see if we see shadow somewhere here. We got shadow here. There's a shadow. So if you want to see shadow, cannot access the shadow no such file or directory ls. Oh no, we need to do /etc. Then that is the file, right? This old version, this is a new version. So actually you cannot read, but as the owner and the group, sudo's group can read the content of this shadow. So if I want to do etc shadow, but I need to read, right? So there is an action. So if I say more, then I can see some of those. For example, this guy. Okay, this is a login ID and password from here to all the way. This is encrypted, so you cannot see what it is, right? There's a password, and then group is also possible in the group ID. For example, if I want to read group ID, also sensitive file, let's see, ls-l etc group, then group, or anyone can read the group. So even you can read it. So what you can do here is more etc group, then you can see the group ID. So right now student group is this is a student group name, and group ID is this. Name of the group is faculty and group ID 1004. There's other groups already defined by this Ubuntu operating system itself. For example, sudo, there's a group. I am in that sudo. Okay. So that is that. And file permission. As we looked at, file has first character tells us some characteristics of the file. So we'll look at that. If there is a dash only, which means that is a file, that is a primitive file. D for directory and L for link, and so on and so forth. And after that, second, third, and fourth character tells us some of the action permitted to user. So read and write, those two actions are permitted to the user. And the next three, read, write actions are permitted to the group where this guy is. And then last three is for the world. Okay, you can change this using chmod command. If you are the owner or anyone who has a super privileges can change the mode. So command to change the mode is in this way. chmod, and you can do, for example, G for group plus. So I'm going to add the privilege to the group. So what kind of privilege? Read and execution. That is the way that we can do. Okay. Or we can use some of the code, something codified. So we can say there's a sticky bit. Originally used to lock file in memory, now used on directories to limit deletes. If set must own file or directory to delete, other users cannot delete even if have write. Set using chmod command with plus T flags, then that is a sticky bits, so that you can see here directory listing the include T or small t or capital T flags, then that is a sticky bits. What it does is that lock the file in memory, although you have so it is a limited to delete. It's a limit to delete, what it says here. Okay, so only apply to specific directory, not child directory, if you want to do. So that is a sticky bits. And a number file permission is also something that we have to understand. When you use a chmod command, the chmod command may be able to receive number, numeric file permission number. Okay, so instead of for example these things, in this case, oh, I need to do G plus all X, we need to have a plus sign and some of the permission, or minus sign, some of the deletions. That type of things needs to come with chmod command, but instead we may be able to use some of the bits. Okay, so three identities: owner, group, and world. Three privileges possible. It's not really for that. So for example, if you say number 4 for, I mean, if you want to add or remove the privileges like read, write, or execute, then instead of all WX, you may be able to use a number. So number 4, if you say number 4, then that is read. Number 2, that is write. Number 1, that is execute. Then someone may ask question, how come I would do more than one actions to grant or revoke? Is it possible? Yes, you can do that. You can do, for example, if you say 1 only, then that is execute, right? 2, then that is write, as we look at here. Number 1 means execute, number 2 is write. But we can add one of those, or 3 all. If you add 1 plus 2, number 3, therefore 1, which is execute, 2 write. If you say number 3, which means the grantee is available for execution and write. Number 4, then read. If you give number 5, then 5 can be constituted by 2 numbers, 1 plus 4, right? There's no other way that you could do with the primitives, right? There's no way that you can, well, number 5 can be made 2 plus 3, but what is the case there? Then 3 means 1 plus 2. Then it is not the case. The way that you can have 5 is there any way that you can have the smaller numbers but more privileges? So one more distinctive privileges. 2 plus 3 will be 5, but there is a duplication, number 2 and number 2, which is not the case. Any distinctive numbers, only ones, therefore adding them all will come up that number, then that is the privileges, that is a compound of privileges. So 1 plus 4, which means execute and then read. If you have a number 6, then write and read. If you have a number 7, then all of those, read, write, and execute. Those things can go with CH mode. Okay. CH RP, if you want to change a group, then that is possible doing this. CH group can be done only by super user. CH, if you have a $sign here, then I mean particularly in this slide, that means each individual can do. You can change CH, you can change CH on, or you can change CH mode, right? So if you want to see what is a CH, then you can see the manual. Man CH, then you can there is no such. Man CH OWN, man CH OWN, so that you can see the manual, which is change file owner and group. So you can read this. At the end there may be some example. Change owner, yeah. Alright. So what we will do here, PW is mine, right? Oh, I need to go back to, yeah, this is me. So I want to make a directory to practice those. Next slide is for the make directory. So I can make directory 321 so that I can see 321. What is the permission code? 321 can be read and execute by all. So you can read this also, all of you, right? But if I want to change this, saying that, oh, this is very, very important. So if I want to change mode chmod for that particular directory by saying let's get inside cd 321. So there's nothing. Let's try to create one file. You can create using a VI editor. That's what I ask you to do. So you can do, for example, a.txt. There's a VI mode, and there if you type O, then from there we can insert. So we type, hey, this is a sample file written by Jae-yoon, and you type whatever you want to, and then if you are done and save and exit, then simply press escape button. Therefore that disappeared, right? If you want to continue to add, then anywhere move your mouse, and if you want to add, then press I for insert, so that lower left corner you will see the insert indicator. So we can type more. If you're done, then escape button, then that's disappeared. Anytime if you have nothing disappeared, then you can move your mouse, right? If you have move your mouse while you have insert mode here, then your file may be a little bit messed up, right? So keep in mind, you have to be very careful. If it is not currently insert mode, then you can save and exit. How can you save and exit? Simply uppercase ZZ. So shift Z, jet twice, then it will go out. If you type ls-l, then this file is available for me to read, write, but no execution, because it is not executable file, right? And group can read it, and world can read. This is the way that I can use VI mode. But I can simply create a file by the command touch, as you can see here. So if I do touch and t.txt, then that file is created. Not touch t.txt, then that is created. So when I do ls-l, then I have a.text. The size of the file is 61 byte, but if I also have another file that I just touched, therefore created. The size of that is 0. Of course, there is nothing. If you say t.txt, then there's nothing. But if you do more a.txt, then there's something that we already created, right? Here, I can copy the file. For example, I want to copy a.txt file to b.txt, so that this file exists, but the content of this is copied to other file, and the file name will be b.txt. So when I do this, then I have a.txt, b.txt, right, in the same size. If I want to change mode, chmod, and I do not want anybody in the group, anybody in the world, any actions. I do not want any actions on my file. for example, b.txt. Then you can simply give, but I want to do everything that I want. The everything that you want, then numeric permission code is 7, right? There's a first number. 7 means first 3 characters. R means number 4. W means 2. And execution 1. So 4 plus 2 plus 1, then that is 7. The group, I do not want to give anything. Then that is 1. I mean 0, right? 0 means no nothing, right? So you can give no nothing to b.txt, and then ls minus l. Then originally this guy has this, right? It's copied, and then now this guy can read, write, and even execute. Although this is not executable file, but if you change that way, it may, right? But it's not really executed. But permission wise, oh yeah, you can execute it. And then world, I mean the group cannot do anything, and world cannot do anything, right? If you want to change this more reasonable way, for example, not execute, but read and write myself. And then if you want to allow read to group, know nothing to others, what is the numeric permission code? How can you change the permission to the file b.txt? The command again, chmod. I want to do read and write by myself. Then you need to put read means number 4, write number 2, so that 6. You want to give read permission to the group, then read permission is number 4. You do not allow anything by anyone out there, then number 0. And then the file name b.txt. Okay, and then ls minus l. Previously b.txt, the color was changed to green, which is executable. That is the reason. Now I remove that X, so this color coded file name is not anymore in green, but this. And then there's a privilege given to the user and privilege to the group, which is readability only, and no actions to the others. So in this way you can control that. Okay. Another thing that you need to do is ln, link. You can change the link. For example, I want to link. See here. Originally I created file B and file A, and that is copied to B. See, the T is just touched. But if you want to add anything to this file, then you can do echo and I want to be in the file, and then you can do double greater than sign, which is a redirection to the file t.txt. And if you have double greater than sign, means you want to append, right? If you have one greater than sign, then it may create or it may overwrite. Okay, so I have right now t.txt has 25 bytes, 25 characters. So can I do link? So I want to link t.txt from t.txt Okay, that's the other way. So t.txt .txt. So if you see this, then this is original, right? That is linked, but if you do link, then it's a little similar to a copy, right? But if you want to link symbols only, then you need to have ln minus s and t.txt and ss.txt. So see here, t.txt is the original, right? But you have another file, ss.txt, which is a link L, and real file, this is the symbol, but real file location is t.txt. So if you type ss.txt, then that is that. What happens here is that the owner is this guy, but if I want to change let's say hold on, I think this is enough right now, so we'll do more next time. This is exercise. I want you to do that. An editor, as I said, you can learn from man.vi or YouTube or vi command or in the textbook. Chapter, I believe, this is chapter 12, right? Chapter 12, so that you can learn from there, right? VI editor. And then finally, the homework assignments that I want you to do. I want you to create 10 directories automatically. We learned that. Give a permission differently with possible distinct sticky bits also. And then in the first directory, create a plain text file using VI and permit all the world to read execution but no change. That is the first homework and second homework assignments that I ask you to do. Okay. All right. So I'll see you next week. Thank you.